Let's take a look at question 9. For 9 part 1, we have a trigo function, okay, and they want us to solve this. They tell us that these are the equation for two curves that intersect at just one point P. For part A, they want us to use algebra to show that the x coordinate of P satisfy this equation. For part B, they want us to show that e to the power of x equal to 3 is the solution to this equation. And for part C, they want us to state the exact coordinate of P. Whereas for part 2, they want us to solve an integration question. Let's begin for question 9 part 1A. Okay, now we want to find intersection. Whenever we want to find intersection, we have to equate the two equations. So 3 over 4 sin x is equal to tan x plus 1 over 5. Okay, so 3 over 4. Let's substitute the definition. So this is e to the power of x minus e to the power of negative x over 2. Okay, equal to the definition of tan x would be e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x plus 1 over 5. Now we want to eliminate the fraction to simplify this equation. So we'll multiply with the LCM. On the left hand side, we have 8, okay, in the denominator, whereas for our right hand side, we have 5 bracket ex plus e negative x. So the LCM for 8 and 5 would be 40, and for the expression would be ex plus e negative x. Okay, let's begin. Now, here we will have 3 over 8 ex minus e negative x. Okay, let's copy back what we multiply. Okay, copy, paste. Okay, now this is equal to ex minus e negative x over ex plus e negative x. Okay, paste, multiply by 40. Okay, so plus 1 over 5. Now let's paste that, multiply by 40 and ex. Okay, let's simplify this equation wherever we can. So let's see, 8 and 40, that would be 5. So this and this will cancel each other, and this one will be 8. So what we have here is this 15 e to the power of x minus e negative x ex plus e negative x equals to, we can expand this, 40ex minus 40 e to the power of negative x plus 8ex plus 8e negative x. Okay, what we have over here is the expansion for difference of two squares. So if we want to factor it, it would be e to the power of 2x minus e to the power of negative 2x equals to 40ex plus 8ex. We'll get 48 e to the power of x. Negative 40 plus 8, that will be negative 32 e to the power of x. Okay, expand the left hand side and change any of our exponential that's supposed to be a fraction. So it will be 15e to the power of 2x minus 15 over e to the power of 2x equals to 48e to to the power of x minus 32 over e to the power of x. We want to eliminate the fraction, so we'll multiply by the LCM, which is e to the power of 2x. So for the first term, when we multiply e to the power of 2x multiply with e to the power of 2x, that would be e to the power of 4x minus 15. These two will just cancel each other, so it will be just 15 equal to 48. So e to the power of x multiply with e to the power of 2x, that would be e to the power of 3x minus 32, and this one, it will cancel one of the ex, so we will get e to the power of x. Let's rearrange and make everything equal to 0. So 15e to the power of 4x minus 48 e to the power of 3x plus 32e to the power of x minus 15 is equal to 0. Let's zoom out. See, that is exactly what they want us to find. That's it. We are done with part A. Moving on to part B. To part B, right? In part B, they want us to prove that ex equals to 3 is a solution to this equation. So we'll start from the left hand side and we'll substitute this value. So 15, 3 to the power of 4 minus 48, 3 cubed, plus 32 multiplied by 3 minus 15. This is equal to 15 times 3 to the power of 4, 1215 minus 48 times 3 cubed, that is 1296, plus 32 times 3, that is 96 minus 15. 1215 minus 1296 plus 96 minus 15, that is equal to 0, which is our right hand side. Therefore, ex equal to 3 is proven to be the solution. Okay, moving on to part C. In part C, they want us to find the exact coordinate of P. So we know ex is equal to 3. Therefore, x is equal to ln 3. Let's find out our y value. So what is our y value? Let's take this one. This one already expand. So 3 over 4 bracket. Okay, ex minus e negative x over 2. So this is equal to 3 over 4. 3 minus 1 over 3 over 2. Okay, let's use our calculator. 3 over 4. 3 minus 1 over 3 over 2. Okay, let's close our bracket, equal to 1. Therefore, P is equal to ln 3, 1. We are done with part 1. Moving on to part 2. Now we have an integration question. Negative 4 to 0 e to the power of 1 over x squared dx. We want to prove that this should be equal to e to the power of negative 1 over 4. Okay, let's start by substituting. Okay, we're going to use substitution method. So let u equal to 1 over x, which is x equals to negative 1. If we differentiate, right, du dx, we will get negative x negative 2, which is negative 1 over x squared. By rearranging this, we will get dx is equal to negative x squared du. Let's replace this into our integration. Okay, so now we will get EU over x squared. Here would be negative x squared du. Okay, we can cancel this, but we still have the negative. Be cautious of that. So we have negative, okay, EU du. When we integrate this, we will get EU, negative EU. Remember that we have to substitute back our, okay, we have to substitute back so that our equation or our answer would be in x. So it would be negative E1 over x. Now we can write down the limit. The limit is negative 4 and 0. But if we replace 0 into this, you notice that we're going to get 1 over 0. We cannot have that. So what we're going to do instead is this. Okay. So it would be limit t to 0. Okay. Negative e to the power of t. Okay. Minus e. Okay. Minus negative e, negative 1 over 4. So here I will get limit. Okay, or here it should be 1 over t. Okay, negative t close to 0, negative e 1 over t plus e to the power of negative 1 over 4. Let's figure out our first term. Okay. Now, let's refer to our limit. Our limit is from negative 4 to 0, right? So, negative 4 to 0. So, that means we are approaching 0 from the negative side. So, as t get closer to 0 from the negative side, what will happen to our 1 over t? Okay. So, let's recap our 1 over t function. 1 over t function. Okay, let's draw this. Rational function would look like this. This is where our 0 is. So, if we approach to the 0 from the negative side, it will be, okay, negative infinity. Okay, next. As we approach, okay, as 1 over t approach negative infinity, what will happen to e? Okay, to the power of 1 over t. So, now we will refer to our exponential function. Exponential function look like this. But now we want to approach to negative infinity. So it will get closer and closer to 0. So this one would be 0. Now we can conclude that this one is 0 plus e negative 1 over 4. Therefore, this is equal to e to the power of negative 1 over 4. We are done with this question. Let's just mark all the answers. Okay. So this is the answer for part 1A. Okay. We have proven. So B, nothing. Okay. C is that one. And 2, we also proven that it looks like this. That's